Solving radical equations. So how do we get rid of a radical equation? We have to use a square. So we use a square to both sides. That cancels out the radical. And so you get 25 equals x plus 3. Minus 3 on both sides. You get 22 equals x. Now it's okay that you have square roots on both sides. In this instance, how do I get rid of a square root? You just square both sides. And we get our values here. Now you just solve for it. So add x to both sides. Add 7 to both sides. And you're going to get 18 equals 2x. Divide both sides by 2. You get x equals 9. Now, one thing that we have to check for is extraneous solutions. Sometimes, because we know that a square root has a domain restriction, when we have equations that have possible domain restrictions, we might get solutions where algebraically they make sense, but when you actually apply it, it doesn't work. We call those extraneous solutions. So you still have to plug them back in and check. So let's verify this one. And I know what you're thinking. You're like, Mr. Duval, do I have to check? The answer is yes. You have to check every single time. Unfortunately, you have to check every single time. Now, the checking part, it will get a little bit easier in the future, like I promise. See, so that works too. For number 2, you want to isolate the square root first before you square both sides. So now you can square both sides, ... Don't forget to check for extraneous solutions. For problem number 4, don't let it deceive you in the sense that it's like, wait a minute. When I square both sides, now I have this n plus 4 squared. Remember, that's n plus 4 times n plus 4. We have 2 of them. So you actually have to multiply it out. Now, by solving, or as we are solving this square root equation, or this radical equation, if you notice, it turned into a quadratic. That's okay. We just now need to think to ourselves, okay, how do we solve quadratic equations? Oh, I want it to equal 0. So we subtract 3 on both sides, subtract 10 on both sides. So we have 0 equals n squared plus 5n plus 6. And then now that factors. So n equals -2 and -3. Now we have to take those and you have to plug them back in and see, do they work? So if I plugged in -3, -3 squared is 9. So it's not squared, sorry. -3 is -9, -9 plus 10, that's 1. Does that equal -3 plus 4 is 1? Okay, that works. -2, I get -6 plus 10, which is 4. If I plug in -2, that equals 2, but the square root of 4 is 2, so there you go. So yep, both of them work. Now on problem number 5, you're going to have to essentially get rid of the square root twice. I know it's a little annoying, but I'll walk you through it here. So we want to isolate a square root first. So I'm going to add that to the other side. Okay, now I can get rid of this square root. So that turns into k minus 9. But this, remember, because it's squared, means we have 2 of them. So multiplying that out, -1 times -1 is 1. -1 times root k is minus root k. -1 times root k is negative root k. And then root k times root k is plus root k squared, but now the square root and the square cancel out. So that equals 1 minus 2 root k plus k. And that equals k minus 9. Well, I now want to isolate this square root again. So I can subtract k on both sides. I can subtract 1 on both sides. And so now I get negative 10 equals the square root of k. Or the negative 2 square root k. Divide both sides by negative 2. Now I can square both sides. Now it doesn't matter how many, right? And now you want to plug that back in and verify it. But it actually doesn't matter how many square roots you get. It's tedious. It's annoying. I can give you 5 square roots. Very annoying. The strategy is every time you want to isolate a square root, and if you just keep doing that over and over again, they slowly start canceling out and disappearing. It's just tedious and annoying, and it takes time. So the strategy is always to isolate a square root, square it, continue to isolate a square root, square it until you have no more square roots. Now looking at 6. Now I'm multiplying that out. Remember, this is r minus 4 times r minus 4. Now if I subtract 10, and if I were to add 13r, you get 0 equals r squared plus 5r plus 6. So this again will equal r plus 2, r plus 3, so r equals negative 2 and negative 3. Now we have an issue here, and here's the issue. If I go to test this, if I plug in negative 2, 10 minus 13 times negative 2, I get negative 2 minus 4, which equals negative 6. A radical will never equal a negative number. So if I were to go through this, this is plus, right? 10 plus 26. The square root of 36 is not negative 6. The square root of 36 is 6. So this solution actually doesn't work. And if you notice, when you plug in the negative 3, the same thing's going to happen. So actually, in this case, there's no solution. For the difference quotient here, we have f of x plus h minus f of x all over h. Well, my f of x plus h is going to be 4 over, we plug in x plus h, so that's going to be 4 over x plus h minus 8. And so now I can plug these in. 4 over x plus h minus 8 minus f of x all over h. And so now we're going to multiply by the common denominator. That's the strategy. It's unintuitive, and what we do next, we just have to memorize that the strategy is to multiply by the common denominator. Now when you distribute this, things will cancel out. So you get 4 times x plus h minus 8 times x minus 8 over x plus h minus 8 minus 4 times x plus h minus 8 times x minus 8 over x minus 8. Those cancel out. Those cancel out. So you get 4 times x minus 8 minus 4 times x plus h minus 8. Now we distribute. I'm just going to write the denominator. So you're going to get minus 4x minus 4h plus 32. And so this, you're going to get 4x and then minus 32. So the 4x's cancel out. The 32's cancel out. So you get negative 4h over h times x plus h minus 8 times x minus 8. The h's cancel out. So you get negative 4 over x plus h minus 8 times x minus 8. And there's your difference quotient.